Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Rimondi Fauzia, NRP 57 from AAP's PANS, Surabaya. And my lecturer is Mr. Rengga Asmara, ASCOM OCE. In our second meeting, the theory meeting, we will discuss about database design. What is it? Let's go. Objectives. So in this meeting, we have our purpose. What is it? It's to understand rules of information system in organization, and second is understand database design process. We have main subject. To limit our discuss. First is introduction. Second is rules of information system in organization. And the third is database design process. Introduction. Database design activities using a systematic process called design methodology, where the target database is set to RDBMS, ORDBMS, or ODBMS. What's the difference between those DBMS? So, RDBMS is Relational Database Management System. So it's DBMS that have relation to another DBMS. And the second is Object Relation Database Management. And what's the difference OR with O only? So there are no relation in ODBMS. It's different on RDBMS. See, like what I tell to you. Introduction. Design methodology. Using a tool such as Designer 2000 from Oracle, ERWIN, PPWin, and Paradigm Plus by Platinum Technology and others so on. Rules of Information System in Organization. So, we have 1. Organizational context for the use of database system. Information Resource Management, or ERM, introduced by large organizations as a key to the success of business management. There are several reasons why. 1. Data is considered as a resource collaboration and management and control for work done more efficiently within the organization. And second, function in computerized organization as data availability requirements large and up to date. Third, as data graph and application of more complex as data graph and application of more complex relationship of the data necessary model and organize. And fourth, there is a consolidation of the information resource in multiple organizations. See what I bought. See the vortex. Modeled and organized. It's the function of database system. It's the background why we need database system. Next. In that time till now, database system provides a new application, namely 1. Integrity of data in multiple application into single database. So the many of data, multiple application, we can make it to a single database only. And the second is the development of a simple to use high level language such as SQL structured query language. And the third, the possibility to browse and queries supported by managers in processing large production level transactions. During 10 to 15 years in the 1970 till 1980, the development of the database includes 1. The personal computer and software products such as database such as Excel by Windows, Fox Pro, MSQL, Access, or SQL. Sorry, it's my SQL. And 2. DBMS distributed and client server as an option opener distribute to the database to multiple computer systems to control better and faster local process. And the third, some organizations are now using the system data dictionary or information repository, which DBMS means is set data metadata is data which describe the database structure, constraint, application, authorization, and so on. 2. Cycle information system. Cycle information system called macro cycle, where the cycle of database system refer to the macro cycle. Microcycle includes several steps. There are six steps there. 1. Feasibility analysis. 2. Requirement collection and analysis. 3. Design. 4. Implementation. 5. Validation and acceptance testing. 6. Deployment, operation, and maintenance. Still the cycle up on if there's cycle information system, we have cycle application of database system. Activities associated with the cycle of the database application system include the following stage. 1. The system definition. For the user interface, response time constraint and the need for storage and processing are identified. And 2. Database design. Logical and physical design of the database system of the DBMS is ready. And the stage of 2, we have the logical and physical design is have to be ready with AR model. And the third, database implementation. This is the phase includes the process of determining of definition of a conceptual database. So we make a drawing, a concept, a design to the implementation, to the reality. External and internal, create an empty database file and implement of a software application with the software. 4. Loading or data conversion. The database is populated primarily to store data directly or modify an existing file system format to the database. 5. Application conversion. Application software from the predecessor system convert to the new system. 6. Testing and validation. Of course, we need a testing and validate is our is our program, is our database is okay or not. So this fase we test and we validate our database. 7. Operation. Nah, we have to operate. The database is ready, so we can operate the system and application. And the last, of course, we cannot leave our database system and go. We have, of course, to monitor and maintain during the operational phase. So the monitor and maintains is the same time with the operation. Second subject, database design process. So what's the purpose? What is for the database design? One, it's for meet the needs of user and the information content of a particular application. Two, to provide information structure of natural and easily understood. Third, to support the processing requirements and performance objectives such as response time, processing time, and storage space in database. There are 6 main stages in the design process in database. 1. Collection and analysis needs. 2. Conceptual database design. 3. Selection of DBMS. 4. Mapping data model, also called logical database design. 5. Physical database design. 6. Implementation and tuning database system. Stage 1. Collection and analysis of needs. Activities that are part of this stage are major application areas and user groups that will use the database or what work will result identified. 2. Existing documents relating to the application studied and analyzed. So we analyze the document user give to us. And 3. The current operating environment and the planned use of the information after we get the information we plan. 4. Reading response to questions. Sometimes group determine database of potential user or groups of others. Stage 2. Conceptual database design. Phase 2A. Conceptual schema design. So in the stage 2, there are stages again. The first stage is concept schema design. The purpose of the conceptual schema design is a complete scheme of the database structure, semantics, and the interrelationship constraint. It depends on the DBMS being used. In the design phase of the database, it's necessary to use high-level conceptual data model with the following characteristics. 1. Expressiveness. So we have to be expressive and innovative. 2. Simplicity and understandability. Of course, what we have what we had make it have to be very simple and understand to our users. And 3. Minimality. Minimality minimality is can be minimality calls and and simplicity. We have to make it minimize. And 4. Diagrammatic representation And 5 is formality. Even we have expressive, innovative, creative, we have to be formal to our user. Next, approach to the conceptual schema design. There are two approaches for designing a conceptual schema, which is derived from the needs of the collection. The first approach is a centralized scheme design approach, one shot, where the needs of different application and user groups at stage 1 are combined into a single set of requirements before design begins scheme. 2. The second approach is the view integration approach, which need out which not be combined. During stage view integration, schema parts combine into a global conceptual schema for the entire database. Stage 2b. Design transaction. The first pause of the phase 2b, in which the process is carried in parallel with phase 2a to design characteristics of non-database transaction applications with a DBMS independent manner. The most important part of the database design is determine the characteristic of the transaction function earlier in the design process. This ensures us our database schema will include all the information required by the transaction. We have stage 2 just before, and now go to stage 3, selection of DBMS. Selection of DBMS based on several factors, some technical, economical, and organizational policies. Technical factors related to the accuracy of the selected DBMS, which includes technical factors are the type of DBMS, relational, object, etc. Storage structure and access paths are supported DBMS, the availability of user interface and programmers, the type of high-level query language, the availability of development tools, capabilities related to other DBMS through standard media, other media, preferred provider architecture associated with client, server, and so forth. Stage 4. Mapping data model. It's logical database design. Process mapping into forms. 1. System independent mapping. In this form, the mapping does not take into consideration the spatial characteristic. I will repeat again. System independent mapping. In this form, the mapping does not take into consideration the spatial characteristics and/or special case applied to the implementation of the DBMS data model. 2. Tailoring the schemas to a specific DBMS. DBMS implement different data models using spatial modeling. Stage 5. Just before we have logical database design. Now we go to physical database design. The following criteria are typically used to guide the selection of physical database design. 1. Response time. It's the time between the delivery of database transaction for execution and receipt of the response. 2. Utility storage space represents the amount of storage space used and the database file structure on the disk access path, including indexing and access other paths. 3. Transaction throughput represents the average number of transactions that can be processed every minute is a critical parameter of the transaction system as used on aircraft or bank reservation. Stage 6. Database implementation and tuning. When the logic and physical design is complete, stage 4 and 5, we can implement a database system. It is the responsibility of the DBA, database administrator with database designers. Transaction database should be implemented with the programming of application created by the conceptual specification of the transaction and then write and test program code with DBML commands. If the transaction is ready and data saved to the database, the design and implementation stage of completion and operation stage of the database system starts. Well, we now in exercise. I have been told the theory, so we will do the exercise. 1. Mention 6 stages of database design. It's just before 1. Collection and analyze needs. 2. Conceptual database design. Conceptual is divided into 2 again. First is conceptual design schemes, and 2 is design transaction. 3. Selection of DBMS. 4. Mapping data model. 5. Physical database design. 6. Implementation and tuning database. Which of the stage as the main activity in the database design process? Why? From what I think, conceptual database design is the main activity in the database design process. We have the key, design and design. Because at this stage, there are 2 kinds of design that we will make before you actually choose the DBMS, which is in page 3. The 2 designs are conceptual design scheme and design transaction. Of course, all is the main, but in design, of course, it's the main activity. 3. Why design scheme and application done in parallel? In order to produce a conceptual database schema and generated specification levels according to user needs. Why use implementation independent data model for the design of conceptual schema? Vehicle description of the conceptual schema diagram of can offer good communication between database users, designers, and analysts. Because the high-level data model is usually safe and easy to understand, the concept of the DBMS data model, that lower level, or the definition of the syntax of data communication related to the design of the scheme becomes more feasible. So we use the implementation independent data model because we can we can we can sign the key over good communication and then stepped and safe and easy to understand, and the definition of the syntax data related to the design becomes more feasible. Next, why is the collection and analyze need? First, to identify and analyze user desires to a database as detailed as possible. You can sign in again. Identify and analyze user desire. And 2, Determine the needs, it must first be identified another part of the system information associated with the database system. Next, how do the characteristics of the data model for the design of conceptual schema should be processed? 1. Expressiveness. Data model expressive enough to distinguish difference in data types, relationship, and constraint. 2. Simplicity and understandability. So, so instead of expensive, but it can't be understand, so it's very useless. So we have to make it simple and understand and use the concept. Third, minimality. The model we have to have small number of basic concepts. There are not there are not overlapping with others. Fifth, diagrammatic representation. A model in the form of a diagram notation to show the conceptual schema easily interpreted. And formality. The data model must be represented to formal spatial data. So the concept is determined accurately and not notable. Is it clear? Next, what a difference to main approach in the design of conceptual schema. Now we have two main approach: system independent mapping and tailoring the schemas to the specific DBMS. So what's the difference? In this form, the mapping does not take into consideration the special characteristic or special case applied to the implementation of the DBMS data model. And in addition, tailoring the schemas, DBMS implement different data models using spatial modeling. Sorry, it modeling, I mean. Next question. What strategies to use for designing the conceptual schema of necessity? 1. Top-down strategy. 2. Bottom-up strategy. 3. Inside-out strategy. 4. Mixed strategy. Top-down strategy. Starting with a scheme that contains a high level of abstraction and then apply a top-down provisions. Bottom-up. Start with a scheme that contains the basic abstraction and then combine or add this abstraction. So we can see the different high level and basic level. And the third insight of strategy is a special case of a bottom-up strategy where the attention is focused on a centralized set of the concept more tangible. And mixed strategy, it's the combination. So it can contain top down, bottom up, and inside out. Requirement defined by the top down strategy part of the scheme is designed for each partition based on a bottom strategy. We see that mixed strategy combine the top down strategy and bottom up strategy. 10. Question number 10. Mention the step view integration into the design of conceptual schema. The first is identification, correspondence, and conflicts among schema. 2. Modified view for conformity with the other. 3. Combining view. 4. Restructuring. It's the final step. Next. Mention factors to the BMS package to facilitate the selection of the system information within the organization. Selection of the BMS based on factors, some technical, economical, and organizational. This is the factor to the BMS package. And question number 12. What is the mapping of the data model of the system independent? What is the difference between with system dependent? Independent mapping system is a mapping to the DBMS data model by not considering the characteristic or things that apply to the specific DBMS implementation of the model. So, if the dependent consider the characteristic that apply to the specific DBMS, independent mapping is not. Oh, it's our ending of the second meeting. Thank you.
Thank you.